Welcome back to my YouTube channel. In the course of this video lesson, I'll be solving different practice questions that cut across different topics in chemistry. So let's get into the first practice question. And the question says, what mass of gold is deposited during the electrolysis of gold 3? Please note this, gold 3, Roman figure 3, tetraoxosulfate 6. Okay, gold 3 tetraoxosulfate 6. Note this as well, gold 3 tetraoxosulfate 6. When a current of 15A, 15A means 15 amperes, is passed for 193 seconds. So how do we solve this question? So first of all, we have to know the topic to which this question is from. And I actually know the topic to which this question is from, and I believe you know the topic as well. You can see here they said electrolysis. That means this particular question is from the topic in chemistry called electrolysis. And specifically, which formula will I use to solve this question? It is actually very easy. Now, if you haven't watched my video lesson on the full concept on the calculative aspect of this topic called electrolysis, so it's actually very important for you to go watch that video lesson to understand the rudiments to which all calculation questions on electrolysis works. I've made it very easy there. But in this video lesson, I'm still going to make this particular question very easy for you to understand without stress. So looking at this question, which concept is it from? Because in that video lesson, I classified each calculations based on cases, based on concepts. Like the first one was in that video lesson, I talked about calculations in electrolysis dealing with the first law, that is the Faraday's first law of electrolysis. And after that, we talked about general calculations in electrolysis. After that, we talked about the Faraday's second law of electrolysis. After that, we talked about calculations in electrolysis dealing with volume. And also, we talked about calculations in electrolysis dealing with numbers of moles. So, in this particular question, which case will I apply to solve this question? It's actually very easy. Now, if this particular question is on the general calculation seen in electrolysis, and I'm going to tell you how to know questions under this aspect, is actually very, very easy. Now, to know the concept to which questions under this aspect is being solved, they'll be asking you to look for something, and it is mass. They can actually, at the end of writing the formula, and I'm still going to talk more on it, but you can see they are asking us to get mass because they said, what mass of gold? And also, they gave us this value. This is current. 15 amperes is current. And also, they gave us time. Actually, I'm to use a formula which I want to write on the board. If it was the Faraday's first law of electrolysis, they will give us a constant, which is called the electrochemical equivalent, which is symbolized as Z. But we are not talking about the Faraday's first law of electrolysis, but rather the formula to solve general calculations in electrolysis, which I'm about writing now, and it is mass is equal to, note this, molar mass, or I can simply say atomic mass, okay, times I times T divided by Q times F. So this is the formula to solve this question. And in this particular question, they are asking us to get mass. So what do we do to solve it? It's actually very easy. It's just to input parameters. But before we do that, let's bring out the parameters in the question. And the first of them is the molar mass, or we can as well say atomic mass. It's actually very easy. So which elements are they talking about here? They are talking about gold. Please note this. They said what mass of gold. They did not say what mass of the full compound mentioned in this question. Don't get confused. Whenever you're solving any question in electrolysis, you have to pay attention to that element mentioned, and it was just gold. What mass of gold? So gold, first of all, is symbolized as what? AU. And what is the atomic mass of gold? You'll be given in the question. It is 197. Take note. But if you're not given, please know it. It is 197. This particular question I'm solving is a likely JAMB question. They've actually asked it before. So it's important for you to know this. But even if they do not bring this same question, they can actually bring the same concept to which you use the same formula. So it's important for you to know the formula to solve questions under this aspect. After you are done watching all of those questions I'll be solving in this video lesson, make sure you go check for the individual videos which I've made here on my YouTube channel. So what becomes because I said now the atomic mass of gold is 197, so definitely what becomes the molar mass of gold, which we'll be using in this question, is going to be 197 grams per mole. The reason I wrote gram per mole because the unit for molar mass is grams per mole. Do you understand? So that's for that. Is deposited during the electrolysis of gold 3. Gold 3. Now, because I'm going to talk more on this gold 3. Note this. Remember I said that the symbol for gold is Au. And what did they say? Gold 3. Gold is a positively charged element. Do you understand? So they said gold 3, so it's going to be gold 3 plus, Au 3 plus. If they have said gold 1, I will say Au plus 1. Now, why am I saying all of this? Please note this. Actually, gold exists in two forms. We have gold 3 and gold 1. Do you understand? But in this question, they asked us for gold 3, so it's going to be Au 3 plus. Note this because I'm going to talk more about that particular gold 3 as we solve this question. When a current, so current now, remember current is symbolized as I. Current is symbolized as what? I, and it was 15 amperes, 15A. It's passed for 193 seconds, so the time, T, is 193 seconds. Note this, whenever you have to impute any value for time, the time must always be in seconds. Let us say the time was in hours. Make sure you convert to seconds. And how do you convert hours to seconds? You times by 260. 60 times 60 with the value for the hour they give to you. It's actually very easy. Okay? And Q. How do I get the Q for gold now? Q means charge of the element. What's the charge of gold? The charge for gold is 3. Are you not seeing it? They said gold 3. Note that. So Q becomes 3. I believe you know how I got my 3 now. And the F is a constant called the Faraday's constant. It's something you should not forget, and it is 96500. Do you understand? So what becomes the mass of gold? So mass of gold is going to be, what's the molar mass or the atomic mass? I said 197 times. What's I, which is the current? It is 15 times. What's the T, which is time? It is 193, okay, divided by what's the Q for gold? It is 3. Remember, if it was gold 1, what becomes a Q? 1 times what's the Faraday's constant? 96500 coulombs. So let's solve this question together to get our mass. So what becomes mass? Mass is going to be 197 times 15 times 193 divided by 3 times 96500. That is, the mass we had here is 1.97 grams. Remember, mass should be in grams, so the mass is 1.97 grams. So the answer to this question becomes option A. You can see how we've solved it. It's actually very easy. So let's get into the next practice question. The question says, which of the following substance, or we can as well say compound, has the lowest vapor density? They mention different things here. They mention different compounds. It's actually very easy. First of all, how do we even know what to do to solve this question? I am saying vapor density. Now note this, because this question is calculation. We want to calculate for vapor density. That's what we want to do. So which formula actually relates to vapor density? Let me write it out. To know vapor density, you have to note this formula. Vapor density now will be using VD. Vapor density times 2 is equal to molecular mass, or we can actually say molar mass. Are you getting me now? Vapor density times 2 gives us what? Molar mass. Then they are asking us to get vapor density. What becomes vapor density? It's actually very easy. To get vapor density, we divide by the coefficient of vapor density. And what is the coefficient of vapor density? We divide both sides of the equation. What's close to vapor density is a number which is 2. And here 2 as well. 2 cancel 2. So vapor density VD is going to be equal to molar mass, okay, divided by 2. That's vapor density. So let's calculate for each of the compounds vapor density. But before we do that, there is another issue, but it's not really a problem because they gave us the compounds in words. They did not give us the chemical formulas of the compound. So first of all, we have to basically write out the chemical formulas of the compound. Now, the reason I actually selected this question is because it's actually a JAMB question. It's because I want to still teach you how we can be able to write out chemical formulas of organic compounds. It's actually very easy. I'll be teaching you a trick on how how this is done. Okay, so you have to follow closely. So the first option here is option A, which is ethanoic acid. So what is the chemical formula of ethanoic acid? Please watch closely. I'll be using each part of the board to solve the question. This ethanoic acid. First of all, ethanoic acid belongs to which group of organic compound? Ethanoic acid belongs to a group of organic compound called alkanoic acid. Ethanoic acid basically belongs to a group of organic compound called what? Alkanoic acid. Note this. And what is the general formula for alkanoic acid? Alkanoic acid general formula is ROCOOH. Do you get? And now, if I'm to write the structure of ROCOH, it's going to be something like RO bond C. Now, you can see COO. C is bonding with one of the oxygen with a double bond. I believe you can see the board. And the other OH with a single bond. So this is alkanoic acid, or you can as well say, yeah, alkanoic acid is also regarded to be called carboxylic acid. Do you understand? Alkanoic acids are also called carboxylic acid. So this is the general formula for what now? Alkanoic acid. And from this question, they are asking us to get the compound with the lowest vapor density. So the reason I'm doing all of these things, to be able to, like, when you see questions, you can actually know how to solve them. Now, what did I say? Let me use this part of the board. After solving for each of them, I'll clean the board, I'll solve for the other. So we'll note the value. After solving for one, we'll do it for the others, like that. So here, watch closely. So we just said that alkanoic acid is their general formula, RO bond C, double bond O and OH, right? Now, this is RO. RO basically is called a group. RO is called the alkyl group. Take note. RO is called what? The alkyl group. Now, if I don't write it as RO, I'll write the general formula of RO. The general formula of RO can be actually CnH2n plus 1. What did I say? The general formula for RO is what? CnH2n plus 1. So then, I can actually write this. This place I'm having RO. I can remove it and put this. There's a reason. Now, watch closely. So if I do that, what am I having? CnH2n plus 1. This is the general formula for RO. Bond C, double bond O and OH. The reason I'm doing this is to get the general formula for what now? Ethanoic acid. So ethanoic acid. Now, in my video lessons I've made here on YouTube, I've actually explained that a compound that starts with eth, it means that that compound has 2 carbon. Met, 1 carbon. Prop, 3 carbon. Bute, 4 carbon. I believe you know all of these. Pent, 5 carbon. Heg, 6 carbons. Hept, 7 carbon. Oct, 8 carbon. Non, 9 carbons. And dec, 10 carbons. So in this context, how many carbons do you think this compound will have? It's actually very easy. So moving further, what did I just say? A compound with 2 carbons should start with eth. That means ethanoic acid we are looking at has 2 carbons. So if you observe, please watch closely. I'm trying to form the chemical formula of ethanoic acid. If you observe, we already have 1 carbon written here. So how many carbons should I add to make it 2 carbon? Is not 1? Yes. So that means this N you are looking at here, the N you are looking at this in this formula, it means the numbers of carbon that compound should have. So in this context, now we already have 1. So how many carbons should we add to make sure it's 2? It is 1. Do you understand? So then this place I'm having N, I'll impute 1 here. Please follow. So here we're having H2. So this place I'm still having N, I should impute 1. Do you understand? Plus 1 at the end, and C double bond O and OH. So here I want to just rewrite it the way it is, COH. It will not stress us. So here it becomes COH. Do you understand? So here we are having C1 H2. So 2 times 1, that's 2. So H2 plus 1, that's 3. Do you understand? And here becomes COOH. Do you get? So 1 is negligible. Do you understand? 1 is negligible in the sense that I can actually rewrite it to be CH3 COOH. And at the end of everything, how many carbons do you think this compound has? It has 2 carbons. So definitely this is ethanoic acid. And I know why it's the reason I said it's ethanoic acid because of the functional group, which is the COH functional group. So this is ethanoic acid. So the next thing we have to do is to calculate the vapor density and note the value. Do you understand? So let's calculate the vapor density of ethanoic acid. First of all, you can see vapor density formula is molar mass divided by 2. So let's calculate the molar mass of ethanoic acid. This is chemical formula of ethanoic acid we have deduced together. It's not that I just wrote it. I taught you how you can actually form them in the exam hall. So you have to be very fast as you do all of these things. The reason I'm taking my time so that you catch it very well and understand it perfectly. The next step here is to calculate the molar mass of this compound. Now, this I'm about saying now, you are supposed to know it. What's the atomic mass of carbon? 12. What's the atomic mass of hydrogen? 1. What's the atomic mass of oxygen? 16. So let's calculate together. What's the atomic mass of carbon? 12. You know, if you want to calculate molar mass, you are adding. So 12 plus hydrogen atomic mass, that is 1, and we have 3 hydrogen here, so it's going to be 1 times 3 plus carbon is still 12, oxygen is 16, we have the other oxygen plus 16, and last hydrogen 1. I believe you understand all what's happening. So then let's press our calculator to get the molar mass of the full compound. So it's going to be 12 plus 1 times 3 plus 12 again plus 16 plus 1. We are having 60. So the molar mass of this compound is going to be 60 grams per moles. So how do we calculate vapor density? Which is the formula? Density Vd is going to be molar mass divided by 2. Okay, it's actually easy. I've written down the formula already. So Vd will now be equal to 60 divided by 2. Remember, 60 is the molar mass of the compound. So 60 over 2, that's 30. Okay, that's 30. So the vapor density of ethanoic acid is 30. Do you understand? So let's calculate for the vapor density of propanol, dichloromethane, and ethanol. You can see that they don't give you the chemical formula straight. They actually gave you in words. So you have to get the correct chemical formula of the compound to be able to get the Vd, which is vapor density. So let's get the chemical formula of propanol like that and get for all of them to be able to get the vapor density. So moving further, how do we get the chemical formula of propanol? Listen, propanol is an alkanol. It belongs to the group of organic compound called what? Alkanol. So what's the chemical formula for alkanol? It is arrow bond OH. Do you understand? You know, alkanols, sometimes you can call them alcohols. Okay, so on these notes, remember I said that arrow is CnH2n plus 1, which is called the alkyl group. So here I'm having arrow, I will change it to Cn. I'm solving for the molar mass of this, so it's going to be CnH2n plus 1. I think what will happen is I'm going to give you the chemical formulas of each of the compound. So I'm going to give you all the requirements to get the molar mass, and you will solve for the vapor density and provide the answer to this question, which is the compound that we have the lowest vapor density. I've solved for option A, so do for the rest option and get the answer to this question. Make sure you solve them carefully. So go over to question number 3, so that will engage you to actually work to get the answers. So there is alkanol, and the bond and the general formula or the functional group here is arrow bond OH. I said arrow is this, right? CnH2n plus 1 and OH. So how do we get for propanol? Remember, prop has 3 carbons. Prop means 3 carbon. So here we are, we have no carbon here, so I cannot say. So definitely this N, which is number of carbons, should be 3. Do you understand? H2 bracket N again should be 3 plus 1 OH. So what are we having next? Well, we have to get C3H. See, watch carefully. 2 times 3, that is 6. 6 plus 1, what is that? 7. So here becomes 7 and OH. So this written here, which is C3H7OH, is the chemical formula for propanol. Okay, don't stress yourself. This is chemical formula for what? Propanol. So what you have to do is to solve for the molar mass and also get the vapor density, which is molar mass divided by 2, and then note your value and do for this option C, which is dichloromethane. So dichloromethane is actually very easy to get the chemical formula of dichloromethane. Now watch closely. Watch closely. Actually, you have to understand that methane's chemical formula is CH4. And if you want to draw the structure of methane, it's going to be, remember, carbon has how many bonds surrounding it? 4 carbons rather. So this is the place. This is methane. Note, this is what? Methane. But in this compound, they said dichloromethane. That means chlorine atom displaced 2 hydrogen atom. That's why it's di. So I can actually come here and remove 1 hydrogen and also come here and remove 1 hydrogen. This is dichloromethane. Do you understand? So if I want to get the chemical formula, it's going to be CH2Cl2. Do you understand? Because in this case, I have C2 hydrogen, that is this, and 2 chlorine, that's this. Do you understand? So get the molar mass of this compound. And how do you do that? I believe, okay, at the end of getting the compounds chemical formula, I'm going to give you the atomic masses of each of them to solve. It's actually easy. And this is ethanol. Ethanol still is very easy. Ethanol is actually an alkanol. And remember, alkanals are also called aldehydes. What is their general formula? The general formula for alkanal is ROCHO. ROCHO, very easy. Then X, remember I said that X should have how many carbon? 2 carbons. So now watch. What was R initially? I said R is CnH2n plus 1. So here is CnH2n plus 1, and we rewrite our CHO. So, and now X has 2 carbons, and remember we already have 1 carbon here. So how many carbon do you think I should add? 1 carbon. So definitely this place I'm having for my N should be 1, as seen in the first example I explained. So C1, N is numbers of carbon atom. C1 is going to be H2 into bracket, N again is 1 plus 1, and here should be CHO. So here should be C1, which is same as C. I've explained that 1 is negligible. H, now 2 times 1, that's 2. 2 plus 1, that's 3. So here becomes C3HO. This is ethanol. This is what? Ethanol. So do well to calculate the molar masses of each of them. I've done for option A. Calculate the molar mass of each of them and divide by 2 to get your VD, and check the value that is the smallest to then know the answer to this question. Make sure you do this and provide the answer in the comment section. It's actually very easy. And I think I have some common elements here like carbon, like hydrogen, like oxygen, and also chlorine. So carbon atomic mass 12, hydrogen atomic mass 1, oxygen atomic mass 16, chlorine atomic mass 35.5. I believe you can be able to do this and provide the answer in the comment section. So let's get into question number 3. Question number 3 says, which of the following gases may not be dried with concentrated sulfuric acid? This is sulfuric acid. You already know the chemical formula is H2SO4. It's actually very easy. Let me interpret this question in a very easy way to understand. They are asking which of these gases cannot be dried by this guy, which is H2SO4. So something will come to your mind. And what is that? It tells you that H2SO4 is actually a compound that dries gases. So it is a drying agent. That's one use of this guy, which is H2SO4. H2SO4 is a drying agent. It is also a dehydrating agent as well. And also another use of this compound is that it is used as an electrolyte in the lead acid accumulator in electrolysis, in study of electrolysis. Do you understand? It is used as an electrolyte in the lead acid accumulator. What's an electrolyte? An electrolyte is a compound that conducts electricity when the compound is in liquid form. Note, electrolytes, they are different from conductors. Conductors, look at what I said in definition for electrolyte. I said that electrolytes are compounds. If I want to define conductor, in physics, I'll say conductors are elements. Conductors are elements. Do you understand? Electrolytes are compound. That's one difference about them. So the point here is this. Let's get back to this question. You have to just note this. It must be noted here that H2SO4 as a compound dries all gases. Dries all gases except, take note, ammonia and H2S called hydrogen sulfide, which turns lead ethanoic paper black. That's one of the tests of this compound, H2S. It turns lead ethanoic paper black. Please note all of these things I'm saying. They are very important. Now, the point here is this H2SO4, I said we've built that it is a drying agent or a dehydrating agent and also used as an electrolyte in the lead acid accumulator, and I've said now that it dries all gases except these two guys. And they're not asking which of the following gases may not be dried by this. So which gas do you think it cannot dry? I've said it already. It does not dry ammonia and H2S. That's what the two gases that this guy does not dry, but it dries all gases. But there is a substance that dries all gases in chemistry. It's called silical gel. So here, what becomes the answer to this question? Option B, because ammonia was mentioned here. I believe you understand now. It's actually very easy. So let's get into the next practice question. Okay, guys, moving further, let's get into the next practice question, which is question number 4. And you will be the one to solve it because I've solved a likely question in question number 1. Okay, it's still you getting mass. Okay, now it is silver. Do you understand? Silver is different from gold. Now, silver is symbolized as Ag. Another question you ask me, how will I know the charge for silver? Silver is Ag, so the charge of silver is actually +1. It is something you should know. That is why I said after watching all of this practice question, because these questions are likely going to come out in the exam, specifically this part of electrolysis, I have been talking about. So make sure you understand the concept of solving questions in electrolysis, because definitely it will come out in the exam. So after watching all of those video lessons and all the questions I've been solving here, they might likely come out in your exam. Do well to go to my channel to watch the full video on how to solve practice question in electrolysis. So let's get into the other practice questions. I just gave you the chart for silver, which is +1. In that video, I listed out different elements and their charges. But in this question, do well to know that silver is +1. And which other thing you have to know? Okay, you have to still know the atomic mass of silver. Silver atomic mass is 108, or we can as well say molar mass 108 grams per mole. So I believe these are the information you need to solve the question. They gave us the charge, and also they gave us time in seconds. So solve it and provide the answer following the same method I used for question number 1, and provide the answer in the comment section. So let's get into the next practice question, which is, which of the following term indicate the number of bonds that can be formed by an atom? Is it oxidation number? Is it valence electron? Is it atomic number? Is it electronegativity? Moving further, it must be noted here that it is the valence electron that is found in a particular element that determines the type of bond that that element should have. Please note this. It is actually very important. Though there is an explanation to this, but it's key for you to know this. It is the valence electron that determines the bond that element should have, not atomic number or oxidation number or electronegativity. Electronegativity here is not relating to this. Electronegativity is on the topic periodic table. Do you understand? This is the tendency of a particular atom to attract electron to itself. It's quite different from what this question is talking about. So note this, the term that has to do with, you know, the type of bond a particular element or atom should have is the valence electron. So that's for that. So question number 6 says, which of the following cannot be obtained by fractional distillation of petroleum? Now, when you talk about fractional distillation, it has to do with crude oil refineries. Do you understand? Crude oil refineries, that's what fractional distillation is all about. That's what it's used for, crude oil refineries. Now, which of the following now does not have any business that cannot be obtained by this process? You know, crude oil has to do with something organic in nature. Do you understand? Organic in nature. Is hydrogen organic in nature? No. Hydrogen is an inorganic element. So definitely this guy is the answer. All of these other options, even if you don't even know the answer before, looking at the other option, you saw ether. That's option A. You saw option B, methane. You saw option C, butane. All of these are organic, but this is the only odd guy here. So definitely option D is the answer. Hydrogen is not obtained during fractional distillation. Now for question number 7, it says the temperature and pressure at which the 3 states of matter coexist together is called triple point. Note this. The temperature and pressure, we have different points. We have boiling point, melting point. We have triple points now. It is the temperature and pressure at which the 3 states of matter comes together. What are 3 major states of matter? Solid, liquid, and gas. So question number next says, discovery of atomic number was by a man called Henry Moseley. Okay, Henry Moseley discovered atomic number. Now, question number next says the main oil for aluminium is called bauxite. The main oil for aluminium is called what? Bauxite. Then you have to know the chemical formula of bauxite, and it is Al2O3.2H2O. This is bauxite. Okay, this is the chemical formula of bauxite, and it is the main oil for aluminium. All has to do with the type of compound that particular element can form. Okay, the element should be in that compound, so it's an oil. Metals have their oils, non-metals have their oils as well. So aluminum is a metal, so it has oil. The main oil is bauxite, though we have different oils for aluminum. We have the likes of corundum. Corundum, chemical formula just this without water. That's corundum. We have cryolite. Cryolite is still another oil for aluminum. Cryolite. This one's chemical formula is Na3AlF6. Okay, this is the ask. You know, this particular question is from metals and non-metals, and this aspect of chemistry is very, very important for you to note them. So let's get into question number 10, and it's tincture of iodine is what? So they're asking us what is the component that makes up tincture of iodine. Now, tincture of iodine is actually used in cleaning wounds in the hospital, and this tincture of iodine is made up of iodine itself and an organic compound called ethanol. So ethanol and iodine forms tincture of iodine, which is used for cleaning wounds in the hospital. You know, iodine generally is used for making antiseptics. Now, for question number 11 says, dash halogen is used for toothpaste production. It is fluorine. Take note, it is fluorine. Fluorine is used for toothpaste production. Question number 12 says, the ore for graphite is called plumbago. It's called plumbago. Take note, remember, graphite is one allotrope of carbon. To be specific, the crystalline allotropes of carbon. We have two major crystalline allotropes of carbon, which is graphite and diamond. So let's get into the next practice question, which is question number 13, and it says, the coal mailing found in Nigeria is called lignite. Take note, lignite can also be regarded to be called brown coal. It's also called brown coal. Okay, that's for that. And question number 14 says, dash allotrope of carbon is used for cutting metal. It is diamond. Diamond is very, very hard. So it can actually be used for cut metals, jewelries. Do you understand? It's actually very important for cutting metals because of the hard nature. So question number 15 says, dash gas forms dense white fumes with ammonia. Ammonia is NH3. It's actually HCl. Take note, HCl is an acid, and acid turns what? Blue litmus paper red. This one properties of acid, physical properties of acid, to actually test for acid. What are other physical properties of acid? Acids basically, you know, they have sour taste, and also the concentrated form of acids are corrosive. That means when they touch the skin, they can burn the skin. That's what it means, the corrosive nature of acid. And also acids, they have pH value lesser than 7. Do you understand? You know, pH has to do with the degree of acidity and alkalinity of a solution. Okay, so question number 16 says, dash compound traps CO2 and SO2. There are two sets of compounds, NaOH and also KOH. Sodium hydroxide and potassium hydroxide can actually be used to trap these two gases. Take note, is important. Now, what do you call this now? Here is the gases used in Fountain's experiment. There are two major gases. The first one is ammonia and the other one is HCl. Two of them are important in Fountain's experiment. Note it. You might be asked, so note that. Question number 18 says, the empirical formula for benzene is what? Remember, benzene is an organic compound, and benzene chemical formula is C6H6. But now they are asking us for the empirical formula of benzene. Should I say the empirical formula of benzene is 6H6? No. Remember, empirical formula basically is the simplest form a compound can exist. It is the last form a particular compound can exist. So I can actually break this guy further to get something like C1H1. Do you understand? Because 6 and 6 can cancel each other. So we will get C1H1, or we can as well just say CH. So CH is actually the empirical formula for benzene. It is the simplest form we can write benzene. This one is just the molecular form of benzene. The molecular formula, I can actually just say the chemical formula of benzene. The molecular formula, that's word, molecular formula of benzene. But the empirical is CH, because empirical is the simplest form a compound can exist. Let's use another example like this guy, which is C2H2. This guy is called ethyne. Ethyne is an organic compound as well. So if they ask you, what is the empirical formula of ethyne? Can you just say, is this? No. You actually break it. 2 will cancel 2. Then we still have the same thing we got just now, which is CH. That's what I'm trying to say. If they ask you, what's the empirical formula for glucose? Remember, glucose is C6H12O6. So then what becomes the empirical? This is the molecular. What becomes the empirical? We use a number to divide all through. That's what we've been doing. So which number can go through all these numbers? So what number can actually go through? We can use 6 to divide. So 6 here, 1, 6, 2, and also 6, 1 as well. Do you understand? So then it's going to be C1H2O1, which is as we can also say to be CH2O. So CH2O is the empirical formula for glucose, not C6H12O6. I believe you understand the point I'm trying to make here. So question number 19 says, oxides of metals are called basic oxides. Basic oxides. You know, whenever a metal combines with oxygen, it forms a basic oxide. That's the point I'm trying to say. When a metal combines with oxygen, it forms a basic oxide. But oxides of non-metals, they are called acidic oxides. Do you understand acidic oxides? Or we can as well call them acids and hydrides. So here, when a non-metal combine with oxygen, it forms an acidic oxide. Do you understand? Like in the case of metal combining with oxygen, we have Na2O. There's a reason I wrote this. There's a reason I wrote this. I did not just write it. There is a reason. Note this. Na2O is a basic oxide because sodium is a metal combining with oxygen, so it's a basic oxide. So an example of acidic oxide is CO2. Carbon is a non-metal combining with oxygen, so then will form an acidic oxide, also called an acid anhydride. Let's get into other practice questions. Okay guys, moving further, let's get into the next practice question, which is question number 21. And it says the compound is an, so they're asking us what compound is this, what family to which this compound belongs to. It's very easy. Once I say a particular compound, I actually know the family to which the compound will belong to, due to the fact that I understand different group of organic compounds, their homologous series. Now let me show you something. This option A, what is it called? Alkanone. Now this is the general formula for alkanone. Here is it. It is ROCO prime. Please watch closely. Let me draw the structure of alkanone. At the end of doing all of this, you'll be the one to solve it to get the answer. It's simple. Okay, now if you're just joining this community and you haven't yet subscribed to this channel, do well to click on the subscribe button and also share these lessons with your friends. It's going to help you all improve for the forthcoming JAMB exam and other JAMB exam to be written. So make sure you watch this video till the end. So let's draw the structure of this. It's going to be arrow bond carbon, and I know see that carbon and oxygen are together. Now notice this, the bond that connects carbon and oxygen atom always is a double bond. Note this. So, and it's actually bonding with it upward here. Do you understand? And this carbon is bonding with the other arrow, which is R prime. Both of the arrow, they are the same thing. They are called alkyl group. Arrow is called alkyl group. What's an alkyl group? Is a derivative of alkane that lost one hydrogen atom. But the point I'm just doing this to differentiate the arrow. Both of them are the same. So I've done something for option A. Option B, you know, alkanoids, they are also called esters. So what is their general formula? It's actually ROCOO. Okay, prime as well. So what are we having for the structure? Arrow will bond with carbon, and carbon, I said that is going to bond with oxygen with a double bond. This first oxygen, and this same carbon will not bond with OR. Do you understand? Please watch closely. It's very easy. Option C is alkanal. Here is the structural formula for alkanal. The general formula is RO2. I think one of these lessons we've talked about this. Alkanal is RO2, so it's going to be R bonding with carbon. And what type of bond does carbon bond with oxygen with? Okay, O. And lastly, H as well. I believe you understand what I'm doing. It's simple. Remember, carbon and oxygen bond together with a double bond. That's why I'm always doing this. And lastly, here is for alkanol. So it's going to be arrow bond OH. All of these now, as you're seeing them, don't forget them. Arrow bond OH is the general formula for alkanol. So here, when during the structure, it's going to be arrow bond OH as well, which we've done, nothing much. So with all of these information, let's try to answer this question. Which of these drawn on the board look like this compound? It's simple. Watch. It's very simple. What did I say? Arrow signifies alkyl group. So let's work towards option D first. Let's check option D. Now this is the arrow. That arrow is this part of CH3. Do you understand? You know this upper part is not CH3. Yes, this one CH3 is called an alkyl group. And that alkyl group you are seeing there is called methyl. If you watch my video lessons on naming organic compound, I've explained this thing many times. So this is methyl and this is arrow. And this other one at the end is not still methyl and it is another arrow. Just another arrow. So now, does it look like this? Now, let's say that CH3 is this arrow, this first arrow. And are you seeing OH in this part? Are you seeing OH? No. So option D will be out. So option C, which is for alkanal. So let's work towards it. Let's say arrow is this CH3, okay, and bond C double bond O. Yes, I'm seeing that. And at the end, what element should we say at the end? H. Are you seeing H? No. So this is wrong as well. So alkanoid, let's check. So arrow, which we're having here, bond C double bond O, which I can agree to that. And at the end, it's supposed to be OR, okay? There's supposed to be an oxygen here. Do you understand? So the point is, it's not two oxygen you're seeing here, but here, how many oxygen can you see in this compound? One. That means this is out. So without even checking, this is the answer. Option A becomes the answer, because let's check together. It is very easy. This is the first arrow, which is CH3 bonding to, carbon bonding to O. Are you not seeing at the center? And at the end, this another arrow, which is this arrow at this other side. I believe you understand what I'm saying, talking about. It's very, very easy. So the answer to this question becomes option A. Looking at it, you can even see that option A look like this. Look like what they gave us for the compound. Is very easy. So let's progress to the next practice question. Now, question number 22 says the compound that will react with sodium hydroxide to form salt and water. Now, with this, I'm thinking of neutralization reaction, because there's something that should react with sodium hydroxide. Sodium hydroxide is a base. So something what react with sodium hydroxide to form salt and water. What react with a base now to form salt and water? That's acid. So you're actually looking for the compound that is an acid. Is option A an acid? C6H12O6. I've said this many times. C6H12O6 is glucose. Is glucose an acid? No. So option A is out. Option B, at the end, I saw OH. Here, this compound is actually an alkanol or an alcohol. So did I say is alcohol that react with base to form salt and water? No, I said acid, acid. So option B is out. Option C, I can say double bond here. So this compound is an alkene or an olefin. This bond is called an olefinic bond. So it's out as well. We are not talking about alkene reacting with sodium hydroxide with a base to form salt and water. We said acid, and this guy is the only acid here. So definitely this is the acid that should react with it to form salt and water. Do you understand? But when this acid reacts with this guy, which is an alkanol, when it forms ester and water, that reaction is called esterification. But this reaction we're looking at right now is called neutralization. The reaction whereby an acid reacts with the base to form salt and water. Neutralization reaction. That's for that. So let's get into the next practice question. It says the hydride formed by a metal is simply called an ionic hydride. Note this. It's called what? An ionic hydride. But hydrides formed by non-metals, they are called covalent hydrides. That's for that. So the isotope of hydrogen that is radioactive is called tritium. Okay, it's called tritium, and the symbol of tritium is H31. Okay, question number 25 says the oxidation number of hydrogen in peroxides is -1, but oxidation number of oxygen in most other compounds is +1. Note this. But in peroxide, it is what? -1. A good example of a peroxide is H2O2, which is called hydrogen peroxide. So question number 26 says dash halogen is used to treat goiter. The halogen here is iodine. Goiter is a condition that affects the thyroid gland. Remember, the thyroid gland is located at the neck region. Do you understand? The neck region of the body. So if the thyroid gland is affected, then it can lead to goiter, which is due to the deficiency of iodine. So to treat it, we give the person diet that contains iodine. Do you understand the point? So that must be noted. And iodine is an halogen. So 27 says dash vitriol is used to treat anemia. It is actually green vitriol. Take note, green vitriol is used to treat anemia. Green vitriol, basically, chemical formula is iron sulfate .7H2O. Note this, iron sulfate, FeSO4.7H2O. Next question says the chemical formula for washing soda is this, Na2CO3.10H2O. This is washing soda chemical formula. And the question number 29 says dash process is used to produce Na2CO3. It is done by a process called Solvay process. Take note, Solvay process is the process that produces this compound. While question number 30 says the electrolysis of alumina to produce aluminum is basically done by a process called Hall's process. Question number 31 says soft soda is an alloy. True. Take note, soft soda is actually an alloy, and it is used for welding, for plumbing, and also welding. And soft soda basically contains two important elements, and the elements are lead and also tin. Tin is symbolized as Nn. So if they ask which is the base metal, all alloys have their base metal. Note this, all alloys have their base metal. Like for brass and bronze, what's the base metal? The base metal there is copper. Here, the base metal means the most important element that forms that alloy, which is soft soda here. It is lead, which is Pb, while other elements is tin that can actually form it. Do you understand? So that's for that. 31 says acid are proton donor. True, acids always donate proton. Okay, acid always they have proton rich, they are proton rich, so they always donate that proton. Question number 32 says the ability of carbon to form long chain is called catenation. It's called what? Catenation. 33 says convert 300 Kelvin to Celsius temperature. Very easy. To do this, we actually use the formula, which is, Kelvin temperature is equal to degree Celsius plus 273. And what are we converting to? We are converting Kelvin to degree Celsius. So then we'll make it subject. So degree Celsius will now be equal to, 273 will come here. It was plus, it changes to minus. So we are having Kelvin minus 273. What are we having? Degree Celsius will now be, because what's Kelvin? 300 minus 273. So 300 minus 273. That is 27. So we are having 27 degrees Celsius. For what now? This question is simple. This is a question you must know. Kelvin is equal to degree Celsius plus 273. Question number 34 says the base metal of tungsten steel is called iron, Fe. The most important element here that actually forms this alloy called tungsten steel is iron. Okay, what are the two elements that forms tungsten steel? Is iron and also tungsten. Tungsten is symbolized as, is an element which is symbolized as W. So this must be noted. So let's get into the next practice question. Okay guys, let's get into the next practice question, which is question number 35. And it says, an organic compound with a pleasant smell is likely to have a general formula. Now, when I see this, I've seen that, okay, this particular question is still from organic chemistry. And which organic compound have a very pleasant smell? It is esters. Esters have a very, very pleasant smell. Esters have a very, very pleasant smell. What is the general formula for esters? I've said it many times. General formula for esters is ROCOO prime. I can just put something here to differentiate both R, but let's just leave it like that. So the general formula is what? RCOOR. And what does this RO signify? RO signifies what? CnH2n plus 1. I've said this before, so note it. So on this, let's try to look at the option that look like ester, because all of these are a group of organic compounds. So which of them have a very pleasant smell? We said already is ester. So how do we locate ester? How do we identify ester? Now, we already know that ester is what? ROCOOR. So this is RO, which we said already. CHO. Is it looking like this? Is it looking like that thing I wrote there? No, option A is wrong. Here, this guy is actually alkanal. Okay, which is what? Alkanal. Remember, alkanal is what? ROCHO. So this is general formula for alkanal. Option B is CnH2n plus 1, which is RO. And here is COO. And CnH2n minus 1. Is CnH2n minus 1? Is it RO? Is what I said RO is? No. So some person might just take this thing to be RO and then they will choose option B. They will think is the answer. It is wrong, because CnH2n minus 1, that's what you're seeing here, not plus 1, which I said. So this is wrong as well. You can see how JAMB, they said their question. They are very, very tricky. So you have to be very, very careful to get the answer. Option C definitely will be the answer, because option D is none. So option C is CnH2n plus 1, which is RO already. And here is C, here is O, here is O. CnH2n plus 1 as well, that's RO. So RCOOR, that's ester. So the compound here is option C, which is esters. Do you understand? They have pleasant smell. And the ester that smells like banana, there's an ester that have a banana smell. That ester is called pentyl ethanoate. Take note, esters are also called alkanoate rather. So the ester that have a banana smell, pentyl ethanoate. But orange smell ester is called octyl ethanoate. Please note all of this, octyl ethanoate. So let's get into question number 36, which says the colored nature of transition metals are due to what? They have partially filled d orbital. That's why they form colored ions, they form complex ion. Not just the colored nature, the complex nature of them is due to the d orbital. Do you understand? Not just the colored ion, the complex nature of them is due to what? D orbital. So question number 37 says the allotrope of oxygen, trioxygen, can also be called ozone. Trioxygen has to do with oxygen having 3 atoms, and O3 is ozone. Hope you get. Okay, this basically helps us to prevent ultraviolet rays coming from the sun. So this is what blocks it, called ozone. That's forming what we call the ozone layer. Okay, so question number 38 says the purest form of amorphous carbon. Amorphous carbon is simply sugar charcoal. So to tell you that sugar charcoal is actually an amorphous carbon, not just sugar charcoal. Charcoal itself is an amorphous carbon. okay, whereby it's of 3, we have sugar, we have animal, and also we have wood charcoal. Out of all of them, it is wood charcoal, sorry, it is sugar charcoal that is the purest. Take note. Now 39 says the process used for production of H2SO4. We have 2 processes here. The first one is called contact process, okay, and the other one is called lead chambers process. Do you understand? Lead chambers process. For contact process, there is an catalyst used, which is V2O5 vanadium 5 oxide, whereby here there is a catalyst used, which is nitrogen 4 oxide, NO2. So NO2 is the catalyst used in lead chambers process to produce H2SO4, but in contact process, the catalyst is V2O5, okay? Why? Question number 40 says, which of the following is an acidic salt? For you to call a salt acidic, there will be presence of hydrogen, okay? There will be presence of hydrogen. Look at everything. I know you can actually say hydrogen here, but the hydrogen is not standing alone. It's standing with water. So definitely this can be an acidic salt. What is an acidic salt? These are the acidic salt. KHSO4. This is the acidic salt. This salt here is a neutral salt. This salt here is a double salt. You know, double salt, they have water of crystallization, but there is one key characteristic of them. They ionizes to form 2 cations and 1 anion. Cations, remember, they are positively charged. These are the 2 cations, whereby this is the anion. It is negatively charged. How do I call these 2 cations? Potassium is a metal. Aluminium is a metal as well, which is Al3+. Do you understand? So these are the 2 cations. Cations are metals. They are positively charged. Whereby this is the anion forming a radical, which is the SO4 2-. You know, anions, they are negatively charged. So this is the anion. So double salts are salt that ionizes to form 2 cations and 1 anion. And also another way to know them, they have water of crystallization. This is actually a complex salt. This salt is called potassium hexacyanoferrate. So the answer to this question becomes option A. So guys, we've come to the end of this particular video lesson. I believe this lesson was actually helpful to you and also impactful. So if you like this lesson, do well to click on the subscribe button to this channel. Share these lessons with your friends to help you guys improve greatly in your studies. I wish you all success in your exams. Thanks for watching.